Hello everyone, welcome back. I just wanted to continue on the development of the breakout board for the FSM300. We left yesterday's live stream on basically trying to create the pads over here, so I have started to work a little bit on it. And yeah, so let's get started. So what we have over here are the dimensions, and I'm going to try to create a simple board based on what we have. Based on this information that we have over here. So in Altium you can create these pads. What you do is basically click place. There's something called as pads. You click the pad, and in the pad there's these properties, and you choose what you want. That's basically it. And yeah, for some reason I wasn't able to think straight yesterday, but nevertheless I did some internet search and I was like, oh yeah. Alright, so having said that, let me just open this up again. I packed everything. It's good to have the actual thing so that I get a sense of what I'm working on. Just gonna basically zoom this on a little bit. So this is what we're working on, is to create a breakout board so then we can solder these pins onto another board and then form the connections. Right now it's a little difficult to use these pins, so yeah, that's the ultimate goal. So they have 3 on top, and then there is, I'm just gonna click copy this, and then we're just gonna basically paste something of this sort. This will be pin number designator 1, 2, 3. This is gonna be 4. This is gonna be 5. This is gonna be 6. This is gonna be 7. This is gonna be 8, and this is gonna be 9. All right. Looking at the dimensions, they're like basically saying that the distance between the first pin and the last pin is 18 millimeters. So what we have right now is, if I go and click measure distance, this is 18 millimeters, and the distance between each pin is 2 millimeters, which is what we have over here. The distance between this and this is 2 millimeters. What we'll do is we'll do something called as the paper breakout. So what I'll do is I'll take this out, make everything, create the PCB, and then we'll print it on a piece of paper, and then we'll map it with what we have over here with the Excel dimensions to get a sense of whether what is accurate before we send it for fabrication. So we can always do that. All I'm going to do is copy this and place this right here. Now we need to know the horizontal dimensions. So the horizontal dimension is 20 millimeters. And what I can do is look at measure distance, take this and put this over here, and that's 20 millimeters. So it's looking fairly accurate. So now let me just go on and so this is 10, and this is pin number 18. So this is going to be pin 10, pin 11, pin 12, pin 13, pin 14, pin 15, pin 16, pin 17, and this is going to be pin 18. Got it. Okay, so that's the PCB breakout board. What we'll do is go to the mechanical layer, and let's bring this down a little bit. What I also want to do is go to the top overlay and then create a line, something like this. So it just tells us, this is, yeah, so I will have to I think what I'm going to do is just take this, includes locked item. Okay, what's locked? I think that's what we want. And then yeah, and then put this down here. Perfect. So that's the thing. So we do a 3D layout, it's gonna be something of this sort. I think we're fine. I'm also taking reference from the other board as well. So if I do a 3D layout over here, yeah, I'm just gonna delete this for a minute, and that's how it looks. So the pad has got some distance on top, so we don't quite have that right. Oh yeah, do we? Yeah, so the thickness will be, so what I'm gonna do is go in here. Oh, come on. Yeah. Go to the mechanical layer, and it'll also tell me what's the XY, and then there'll be the, this is the XY, then the shape is rectangular, and then we have solder mask expansion. This is 0.05. So we'll go over here and then click all of this, and then we'll just click to solder max expansion 0.0. Yeah, we don't, no, nope, that's not what we want. So that's, yeah, so the height, I'm not too sure where they're getting the height from. Yeah, that little thing over there, maybe not even relevant. Like in these layout, like what's with the pad? So we have the XY, propagation delay. This is a load. Yeah, what do they have for each one of these? And here they have it as also the load, R35. So let me just have a look again. Put this as R. Let me just go and put here as R35. Oh, okay, so it's really small. Okay, got it. So it's just significantly smaller, but same height. So it makes it look relatively small. Okay, I think this looks good. And then we can create another mechanical outline at the mechanical 15. So just go in here, and then we basically go to mechanical 15. Where is mechanical 15? Keep this board over here. Yeah, we just have mechanical 1. I think we have mechanical 15 over here to have that, you know, outer layer. I don't think we need it though. Like this green little outline over there, it just basically says nothing should be placed in between this. So that's really the thing. It's good to definitely go on the top layer, and I'm just going to place a circle, an arc, maybe an arc, yeah. So say that this is number 1. Yeah, something like that. Come on. Okay, and in here I'm just gonna make the width maybe 0.3, or maybe even this is maybe 1 mm. Yeah, and then this is the location. We can just reduce the radius to like 1. Yeah, something like that. So this basically is telling me that this is the number, pin number 1, basically. Anything else? Yeah, I would really like to have the mechanical layer. So what I'm going to do is go in here and then add a layer set. No, active layer, mechanical, add component layer pair, add a mechanical layer. We're just going to call this layer 15, layer number mechanical, layer number 15, layer type is going to be yeah, it's gonna be basically mechanical, so it should be dimension, and we just click OK. And yeah, so what I'm gonna do is go to the mechanical layer, and we're just gonna draw a line, a bounding box around it. So this should be just basically telling nothing. So in another example, basically say nothing should be placed in between this. You know, it's kind of like a box around which let's not place anything around it. Oh, I got it all wrong. Okay, I'm just gonna move this. This is looking good. Then I'm gonna place this whole thing, yes, right in here. Okay, so nothing should be placed around this area. I could actually make this slightly bigger, so it's, yeah, we got the, and just take this and move this, yes, move this in here. I think this looks good. I don't have a 3D object. This will be the top overlay, bottom overlay, top, and the same thing is even if you go over here and then put a 3 layer. It's just, this looks neat. So this is what we have over here, and I put this under I.M.U sensor. So on sensor, I am going to go to the CEVA board over here, click add footprint, and I'm going to browse, and we have the I.M.U sensor in here. I'm going to put the CEVA, just click open and then click OK. So now we, I think, have it. And what I'm going to do is, it's going to be a very simple board. We can open this over here and place this in here. This looks good. So let's look at the data sheet to look at how we are going to basically what connections we want. I don't think I want to put anything on this board. Like for example, if I use the I2C, I got to put a 2.2 kilo ohm over here. I want the flexibility in a future day, because I only have one of this IC. At a future date, if I want to use the I2C protocol, I want to have the flexibility to perhaps put this 2.2 kilo ohms in outside the board, outside this breakout board. So this breakout board is as simple as it is to keep this one basic chip and add the headers. So this is what my intention is, to keep it so we have the SCL, SDA, and just to get a sense of what we have over here with the other I.M.U sensors. What I have over here in the 4 over here has got the SCL, SDK, SDO, SAO. I believe this one, did I use the SPI protocol in here? So, and this one is using the SCK. Yeah, so that's what I made up. I'm not particularly consistent, because yeah, you want to have this as the SCL. Whereas in here with the PH1 I got the SCK, SDA. Yeah, but this is okay, this doesn't have SPI. Okay, so this doesn't have SPI. This possibly might have SPI. So we have this chip select, SDA, SCL, and SDO, SCA. So one is data, one is clock, one is chip select. So I'm just going to go to the LSM 60 MTR. I believe it's got both. So LSM or I.M.U from ST Microelectronics, and just getting a sense of the chip value. But since the dimensions are different, oh, look at this, there's 91,000 in stock. If you guys want to buy it, you can go grab it. It's like any I.M.U sensor right now that is in stock, pretty much go get it, right? Wow, too good. Yes, but since the dimensions are different, it doesn't matter actually. So I'm just going to just create something that's unique to what we have. I'm just gonna minimize this as well, and then go to my FSM, create a header. So I'm just gonna basically miscellaneous connectors. It's okay if it's through hole, it doesn't always have to be SMD. So we're gonna have 4 connector header 4, and this 4 will be, I'm just gonna click the wire 1 2 3 4. Okay, here we would have the CSN. So I'm just gonna extend some of these. So this is CSN, this is gonna be, and we'll just label these guys slowly. Okay, and I'm just gonna click on net label. The same thing over here. So this net label will be CSN. This is going to be MOSI, SA0 MOSI. Yeah, I don't know what RSVR does, but let's look at the data sheet actually. So RSVR, yeah, they don't connect it, right? So the RSVRs are these. Let's look at RSVR. What is it? This looks like some reserved. Oh, let's not confuse ourselves. Let's delete all this. So this RSVR, which is part of the. So okay, so it's reserved. Do not connect. So this is 3, 4, 13, 16, 17. So that is basically 3, 4. Where is 13, 16, 17? What about 10 and 10? So these are all no connects. So that's awesome. So I'm just going to put over here and click RSVR. Wherever there's RSVR, we can like literally just do this. So these things do not need to be connected. I can remove this and I can remove this, keeping the design a lot cleaner. Perfect. So I'm going to say this is also going to be CSN. Actually, you know what? I will look into this. Even though the dimensions are different, we have the SCK, SDA, SCK. Okay, so whereas here we have chip select, SDA and SCL. So this is clock and this is data. Okay, so we'll have the clock. Oh, where am I? Okay, so yeah, I'm just gonna put clock wherever the clock is. The clock will be CSN. This is master out slave. So yeah, we have it. So it's gonna be SCL, SCK, or RXD. Okay, this is the clock. This could be the data line, so it could be master out slave in. Master out slave in. Actually, it's gonna be slave out. So I would put this as master and slave out. So I would actually label this SDA. So it's gonna be master and slave out and transmit. Yeah, so that's gonna be data. I'm just gonna take this, remove this, put this in here. Yeah, and then this is going to be the receiving. So this is going to be SA0 / master out slave in. Okay, and put this in. Yeah, no, we got it. CSN. I think this looks good. Let's annotate this so that we don't have update changes. Click OK. accept the changes, validate, execute, click close, and accept changes. All I've done, click close. Yeah, so I think they're all looking good, and now we just need something as such as VDD and ground. So I am going to just do something like wire for ground, and take this, and since this is also around here, we can literally, you know, just put a wire for ground. Is this connected? Nope. Okay, now it should be connected. They should be connected. Things that are not connected, yeah, like this is, you just have to basically go to grid, set snap grid. It's gonna put this as 0.1 mm or 0.5 mm. Yeah, so this is not connected, and if it's not, come on, view grid, snap grid, 0.125, I don't know, okay, 0.254, 0.254 is the smallest we can, the resolution, and even then it's like, yeah, it's not, it doesn't like, doesn't allow me to like place this. Yeah, these are little quirks that kind of annoy me. Like, how does this work? Okay, and now do I move this? Yeah, okay, interesting. Okay, so this is connected, this is connected. Do we have, okay, yeah, so that means this looks right. Oh baby, because I don't have, and yeah, so this is because there is no pin, and yeah, so now these are connected. We have ground, and now we need to put in the VDD. Place in the VCC, the voltage, and put the wire in here. Now the NRST 16, 17, 18. Oh, is 18? Wait a minute. 18 is NRST, so that's an input. Reset internal pull up. So no, this is not a cross. So yeah, so put here as net label, and this is gonna be an NRST. So now let's look at all the pins that we have not labeled and make sure everything is labeled. And this is going to be net label. This is going to be a PS0/wakey. This is going to be a wire. Put a net label in here. PS1, I don't know what PS1 is. Let's look at the data sheet. PS1, which is pin number 7, protocol select, internal pull down. Okay, so this is where it tells you whether we're using I2C or SPI. And then we have the net label. This is going to be boot N. I don't know what boot N is, or, and here we have HINT, whatever this is, HIT N, and this is an RSVR, so 4 is again not connected, so 4 is reserved, not connected, so 4 is not connected. And then what I'm going to do is something to annotate per se. Actually, we don't need to do this yet. So what does pin number 5 and 6 do? So pin 5 is output is the host interrupt, okay, and 6 is bootloader mode selection. Okay, so it has a bootloader mode selection. And in most of my pins out over here, I have 6 pins, so I think we'll just stick to the 6 pin where VCC and ground is the same thing, and the interrupt. So I like this setup. So we're gonna have header 6. I'm just gonna copy this, put this in here, and this wire is the same as VCC. this wire is be connected to ground. Okay, and then we have the interrupt, which is pin 18, which is the reset internal pull-up. Host interface protocol. Oops. So it's an output, this is an input. Boot in bootloader mode. So the interrupt pin would be, are we trying to reset? So this could be the NRST. So we have a VCC, we have a wire over here. I'm just going to put this as a reset. This can be the interrupt one. Then we got the protocol select and something like that. So just to put them in labels, 2, 3, 4. So this is going to be NRST. So this is going to be the reset. Then we have here as host interrupt, and then this is the bootloader mode. Actually, bootloader mode can be last. This can be the protocol select, and this will be the BOTN. Okay. We have one for this PS0 Waken. So let's look at what this Waken is. 9. Input protocol select 0. Let's select one protocol select. SPI mode processor wake input. Internal pull up. So S protocol select 0. So it's an SPI mode processor wake input. SPI mode processor wake input. Let's have a look at this, like PS1 again. Okay. Or maybe I'll just put here as protocol select. Oh, that's all there is. So SPI mode, okay. Because we do have PS0 over here. Also, PS0 is connected to ground in here. And for SPI, let's look at SPI. We have PS1 is connected to VDD. The Waken is connected to Awaken. Okay. And Waken over here does something. What does the Waken do? SPI mode processor wake input. Okay, so you're waking the thing. So it's an input. So it comes as an external thing. Alright, so we can't use header 6 because we have an extra pin, so we have to use header 7. I think this is how it's going to look. I'm going to put this in here. I'm going to put this in here. Actually, I'm going to cancel this. Put this like this. Cancel this. Put this like this. Okay. And then I'm going to put here as wire. Okay, and this is boot N, and then we have here as okay, so this is going to be, so we have in PS1 and this is going to be the PS0 and Waken. Okay, so pin 9 is the PS0. I think it looks good. So what I'm going to do is just put a bounding box where we have a draw. Nope, we're just going to put a rectangle box, at least something like this. This is going to be the protocols, and this is going to be more or less the power. So this is going to be, so just put a drawing tool. I'm just going to click box over here. We put this as, there's no fill color, but we can put this as medium, and you can just put some text string over here, and then this is going to be the data header. Just keeps our schematic diagram somewhat. I've not done this in others, but I should be doing this, especially when it gets too complicated. So it's a good habit to build, even though this is a very simple schematic. It's like there's literally nothing in here. And this is going to be like, you know, the power interrupt, INTERRUP interrupt header power / interrupt header, something of that sort. So yeah, it's cool. All right, so now let's create the PCB. This is starting out to be a long video. It's also part 2. Where are we right now? Okay, so what I'm going to do is save the project, and let's go in here and we'll do add new PCB to the project. I'm just going to save this as the the FSM breakout board. It's already a PCB, so we already have this. Looks pretty good. I'm just gonna click design, import. This should be literally just one thing. So when all I gotta do is it's this room that's added. We don't need any room. We validate the changes, we execute the changes, and we should be good to go. And we just have the header. Why didn't the actual board come out? So when we have here show, yep, it should be why did I miss something? So when we click a breakout board, design, import, we want to add any rooms, so we're adding this component, unknown pins, execute. Okay, so footprint not found, failed to add. Okay, I think I know what the issue is. File-based thing. I'm just gonna click install. Instead of resistors, I'm gonna have sensors. I.M.U. Yeah, since it's in sensors, I can. This is the schematic library. So in here we should have the CEVA I.M.U sensor PCB lib. Just click OK, click close. Then now that it's in the library, I believe that's the issue. So when we go to sensor, and then if I click browse, I have the I.M.U PCB lib. Okay. So okay, so I have to. Where's the I.M.U? Do I have it? No. Install. Yeah, I did do that. Okay, so and then just gonna click refresh preview, save this, go to the board over here, FSM. What about this? And yeah, this should be connected. So if I go to design, I think it was because I didn't put it into the path. Validate changes. Yeah, I think it should be there, right? Perfect. Here we have it. Okay. And here we go. And CSN. What's wrong with CSN? So this is not connected. So this. Okay. What is wrong with this? Okay, so we'll figure that out. So one thing I want to do is set the dimensions of the board. So let's find out what we want over here. So this is 2.5 centimeters by 2 centimeters. So ideally we want it to be slightly bigger, so it'll be easier to solder and then put the breakout pins. So maybe we could have this at, let me bring this in here. So if we have like headers, so we could have the header maybe around, so we could have this at 3 centimeters, And let me just get the headers. Just give me a minute. All right. So gonna have like some headers like this. So this would be one header. Where would we want to place them? Or you could even have it as a female connection or a male connection. So this would be female connection. So where would you place this? Since this is more, so this would be something of this sort. Place them at least, you know. Yeah, so I would probably put this at 5 centimeters, 2.5, 2.5, and then put this at half a centimeter, half a millimeter, yeah, half a centimeter over here, right at the center. Okay, so I'm just going to make this as 5 centimeters by 5 centimeters. That looks like it. So I'm going to go to View, Grid, Set Global Snap, and just put this as 10 millimeters. And then I'm just going to go to the Edit Board section, Design, Edit Board Shape, and then we're just going to, it won't even be Design, just click Redefine. So it's going to be, where is the starting point? Oh, there's a starting point. So let's start at the starting point. So Design, Redefine Board, and this is going to be 1. This is going to be 10 millimeters, 10, 20, 30, 40, 50, 10, 20, 30, 40, 50, yeah, something like that. Okay, and then we'll take all of this and move this right here. So grid, go to grid, set snap grid, and then here I'm just going to put this as 1 millimeter. So we have our fine control. Put this right at the center, and I'm going to place them somewhere around here. So this is, so we have, it's spacious, right? You don't want to, you know, clump everything all the time, something like that. So we can again go to Width, View, Set Snap Grid, and here I'm just going to put this as 5 millimeter because that's where we want this to be, and we want this to be pretty much at the center, and we want this to be somewhat in the center. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. So this is going to be centered, and this one, yeah, I'll probably have to put something like this, I think. This on top. Yeah, it doesn't have to be perfect, it's fine. So let's go to the keep out area and we'll just draw the line. So in the keep out area I am going to, and this will be okay, and what we'll do is go in here and we'll create arc edges. So that'll be 1 arc, 2 arc, 3 arc, 4 arc. remove this, remove this, remove this, and remove this. All I'm gonna do is select this, select this. We don't need this, we don't need this, we don't need this. And then we can go to design, and then we can go to board shape and define board shape from selected objects. And now we have this nice little it's curved at the edges. Here I'm just gonna place this somewhat in the center. So we have, yeah, it's not quite at the center, is it? So yeah, you want this to be somewhere around here, I believe. Anyways, I think it's something of that sort. Let's start to draw the tracks. So now we'll go to the grid, set global snack grid, and this is going to be 0.254. Yeah, and this is, where does this go? This goes to reset. Okay, so now that we have this, let's go to the design. Okay, so there's a few things we want to do. I want to go to FSM and I want to re-annotate this. So annotation, annotate schematic, update schematic, click OK, click accept changes, validate, execute, click OK, accept changes, click OK, and click close. So this is now P2. Now this is important, so we don't have some P question mark over here. Click design import, we remove the room, validate, execute changes, and then we click close. Okay, so now we've got the labeling right. Next thing we want to do is set the rules. So let's go to design rule check and run design rule check and see what errors do we have. So we don't have anything routed. There is a clearance and short circuit. Okay, this ain't good. So this is a short circuit over here. Okay, so that tells me that I gotta go to this, to the I.M.U sensor over here, and then see what we have in here. Only locks. Okay, delete. Yeah, that's the reason. Okay, so I'm gonna move this. Okay, so I'm gonna move. This is locked again. Okay, so I'm just gonna click console. You delete. Okay, I believe there is even one over here. No. Okay, so let's click refresh preview. Go to the board. Just gonna click design, import changes, move this, validate, execute change, close. I also believe you can do a component action and click update, select the components from library, accept changes. We don't need validate, execute change, click close, accept changes, click close, close. Alright, so anyways, tools, design rule check, run design rule check. We still have short circuit. This is not good. So pad 1 is still not looking good. So we fix this. Okay, let's have a look. If I remove this, similarly over here, just name this as 4. Delete this and just put this and label this as 1. Same thing would be over here as well, or maybe even here, I think. Okay, not here, maybe 7. Yeah. and then so this is what's gonna happen. So same thing over here, same thing over here, and same thing over here. Okay. Control C, let's control this. Put here, put here, put here, put here. So this is going to be 5, 6, 7, 10, 11, 12, 13, 14, 15, 16, 17, 18. Perfect. Now we don't need any of this. Let's go over here. I'm just going to click refresh preview. We could even remove this and just click add footprint. Go to browse, go to I.M.U sensor, click on this, click OK, and yeah, this should do it. I can go to schematic, and in here I believe it's in we refresh it from here, can we? I don't think so. Anyways, I don't think so. So, and here we should go to the PCB, and let's see if I can click on this and go to component action and update schematic, update all, modify, validate change, cannot match pads with new footprint component. Okay, so this is what we're gonna do. We're just gonna delete this thing and just click an import change. There's no point trying to, yeah, and just click close. Yeah, there we go, right? Like, why waste time and energy? Yeah. So so now when we do the tools design rule check, at least there should not be any short circuit, at least I hope not. Good. So short circuit is removed, so there's no clearance constant, and now we just have the unrouted thing. So let's go and start to route them. I'm going to the bottom layer and I'm going to click design tools, polygon. I don't even need to do that. I can just click polygon pour, view grids, net snap grid. Put this as 0.5 mm. Oh yeah, this is I don't think I'll put this as 1 mm. Yeah, this looks good. Polygon pour, so we'll have something like 1, 2, 3, 4, 5, 6 to 8. I don't know what I'm counting, but I was counting something. Okay, and then I don't know what this is going to do. Come on, I might have to do this again. So 1, 2, 3, 4, 5, 6. We can just put this right to the edge. 7, 8, 9, and this can technically go here. Yeah, something like that. Yeah, and then we just click repour, put the net as ground, and repour, and we should be good to go. So that's the bottom layer. The bottom layer is ground, and so that makes everything technically slightly easier. So now let's go to VCC. We can go to track. I think it's a 2-layer board, 1-layer board in my opinion. It shouldn't be a 2-layer board. Sorry, it shouldn't be a 4-layer board. It's pretty straightforward, but at the same time, what I'm noticing is, okay, this is where it gets tricky. So what I'm going to do is basically rotate this like this, and yeah, and the reason being is because there are more pins that are connected to this header, and there are more pins on this side of the board connected to this header. To make sense what I mean, like CSN goes over here, MOSI goes over here, clock, you know, goes over here, MISO goes over there. It's like, there we go. And then this goes over here. This, we have a ground. We don't need to do anything. Edge hint, or rather, you know, I can just put this, goes over here. Boot in goes over here. PS1 goes over here. Ground goes over there. Let's go to track. Awaken goes over there. What are we missing? Just, and then we go to track. Like, this is this like the easiest breakout board ever. Goes over there, and we just have, wait, yeah, that I think should do it. Yeah, so if we go to design rule check, run design rule check, we got 14 errors and they're all solder masks. So so if we just do a 3 thing over here, all we want to do is, yeah, so the solder mask is really small. Guess I could show the solder mask. Do we have things that are showing the solder mask? Okay, I don't know. Okay. Yeah, so I can just go to design rules, and actually let me have a look at the rules again. Where was the rules? Design rule check, run design rule. Oh wait, so this is minimum solder mask. So minimum solder mask is 0.03. okay, this is pretty small, so 0.03. okay, so minimum solder mask is 0.03. you go to rules, and where is minimum solder mask, and here we have here is 0.03. it's really small, but that's what we have. Click OK, go to design tools. Normally use JLC PCB, we just have one right now, and wow, which one is this guy? Yeah, I thought we did this. Why is this? Oh, this is less than 0.03. like, what the heck? Okay, design design rules, so we can just put this as 0.29 or something like that. Apply, click OK, in tools, and then design rules check, and here we have 0. So yeah, that's pretty much what we wanted to do. So this is the FSM breakout board. I'm gonna save this, save the project, save. Yeah, it took me 2 videos because I've literally live streamed the whole right from start to finish. And the next thing what we can do is basically, you know, do a file fabrication output. Could also be the assembly drawing. Yeah, this would not what we want. So, but if we could go to fabrication output, and then we click in Gerber file, millimeters. I just like my things in millimeters. All layers, drill drawing. Get the drill drawing, and then click OK. So it'll produce the thing. And then here we can go to. Yeah, this is not what we want. We can close this. I don't know what the purpose of this might be. Maybe if you've, I don't know. And then we want the NC drill holes, millimeters. Click OK, and here we are. And here we should be good to go. So it does create all these outputs. So these are all the Gerber files. What we might want is to print this out. So if I click, you can also, basically if I just go and click at the 3D layout, yeah, the top overlay is not particularly clear, is it? I thought we would have the top overlay. I'm just gonna close all this. I don't know what this is. So if I go to top overlay, I would want to see this. I don't know why am I not seeing. Oh, I do see it. Okay, so these white things over here. My bad. Allowing me to place the board exactly in there. So yeah, we do see it. So the next thing is, the last thing that we want is go to top overlay, and then we'll just label the pins. So we can go to text, line, string. I'm just gonna do it right now. I don't wanna leave it later on. So I'm just gonna put this as 0.75 millimeters is gonna be the string. And this is going to be SCL, SCK, RXD. I could put this, yeah, I could put this at the bottom overlay as well. Mirror this, and so yeah, I'll just put this like this. So if you go to the bottom layer like this, it'll show you what these pins are, so it's fine. Yeah, and then same thing over here. This is going to be the AMISO/DXD. Okay, and then we can basically align this to the right. And then we have Control C, Control, and this is going to be SA0/MISO MOSI, master out, slave in, and Control C and Control V, and this is going to be CSN. So this is let's go to bottom overlay. Yeah, so what we want to do is make sure these are all, I guess, left aligned, align left, then just put this in here, something like that. So if I go to the 3D, yeah, so we have this nicely placed over here. Similarly, let's do this on this side. I think over here on this side I might have, yeah, I could put this, I'm just gonna put this as ground. This is gonna be the PS0/wiki. And then we have the boot. Come on. You gotta be kidding me. Boot. Then we have here as PS1. Then we have here as HINT and and then we have here as NRST, and here we have the VCC. Ah, come on. Okay. I think it's looking good. What I'm also going to do is click align right, and I'm also going to distribute. So I'm going to click align, distribute vertically, align, distribute vertically. I think this looks perfect. Yeah, so everything is now nicely labeled. We're looking at over here. What we could do is change, say, the color to blue, and this is what it would look like. Yeah, the spacing is like so the spacing over here is like pretty small. So in here we basically do have like very minimal spacing, very good chances of short circuit, but oh well. That's pretty much it. I'm gonna do the fabrication output, Gerber files, layer, all layer, drill drawing, all look good. Generate everything, that's looking good. Click don't save, and then we just create the fabrication output. We create the NC drill files, millimeter, click OK, and that should create the drill files, and here we're also good. Save, done. And yeah, that's I don't know what that was. Okay, and just to make sure that everything is fine, we do a design rule check, run design rule check, and there's no errors. So that's about it from today, and I know it's a long stream. I just wanted to finish it off. I'm using YouTube as a way to keep myself accountable, to get some of this stuff done and improve some of my skills. So yeah, thank you all so much. Do subscribe if you like these types of content, or if it keeps you motivated to do what you want to do. And until next time, take care.